Okay, we just finished the composite functions where you did f of g of x or g of f of x. Basically, you took one function and you replaced the variable with the other function. So I'm going to take this right here, 4n plus 16. I'm going to replace the variable with the other expression. So this is going to replace the n. Negative 16 plus n all over 4. Are you aware that when you multiply by 4 and divide by 4, they eliminate each other? So you have negative 16 plus n plus 16. Negative 16 and 16 add to 0. So does this equal just x or just n? So I would say therefore, which is 3 dots in this pattern, therefore, yes, they are inverse functions. They are inverses of each other. So all you do is you're going to replace the variable with the other expression. Okay, we just replaced the variable with the other expression and simplified, right? That's pretty much all we're doing. So we're going to take one of these. I like the one that has a smaller denominator, but it doesn't really matter. You're going to take one of them and rewrite it, but everything except for the x or the variable. And in place, you're going to put the other expression. So you have negative 4/7 x minus 16/7. Top times top, bottom times bottom is how you multiply fractions. So I think that's a negative 12/14 x. 2 times 7 is 14. How about 3 times the 16? That would be 48. And 2 times 7, 14. And then you have minus 3 halves. I don't know if you want to turn that into 17ths. Or into 14ths, that is. Suppose you did 7 over 7 on this thing. Would they now all have denominators of 14? Yeah, it does simplify. I could have simplified these fractions. 48 14ths. And now this would be minus what? 21 14ths. Is it going to equal just x? It's not just x, is it? I mean, you could probably look at it and see it's not just going to be x. So these are not inverses. Again, if it equals just x, which this one does not, but if they did equal just x, they would be inverses. Look at number 6. I'm going to take one of these and replace the variable. Which one do you want to replace? I'll probably plug it in over here if it's okay. Cube root of 4 times n, and this is all over 2, right? So I'm going to replace it with the variable n with the other expression, which is 2 times n minus 2, and that is cubed, right? So let's keep going. 4 plus cube root. What is 4 times 2? 8. And n minus 2 cubed, and all over 2. Does anybody know the cube root of 8? Because I could break this up. Cube root of 8 times, not the times, the cube root of a quantity cubed. And this is all over 2. So what is the cube root of 8? 2. What happens with a cube and a cube root? They eliminate each other, and I think it's just n minus 2. So I'll bring it up over to here. This is a hard one, but you have the 4 plus, what's 2 times n? 2n. 2 times negative 2, negative 4. What is 4 and negative 4 going to add to equal? 0. So you basically have 2n over 2, It's just n or just x. So yes, they are inverses. That's a difficult one. Okay, we're going to move on if there is one. How about 7? Are they inverses? I don't know. We kind of have to make a decision where we're going to plug in. It might be easier over here. I don't know. Maybe not. Do you want to plug it into this variable, or do you want to plug it into that variable? The one I have started, or? Yes. Okay. Okay, so we have the plus 3, and I wrote everything except for the x, right? And now I'm going to replace that x with the other expression, which is 4 over negative x minus 2 plus 2. So this becomes negative 1, 4 over negative x minus 2, and would that be plus 5? I'm hoping perhaps you can already see it's not going to equal just x, but we have a negative 1. I'm going to take a negative out of these. If I take the negative out, it would become x plus 2. So if you don't mind, I'll take the negative out, put it on top, and call it x plus 2. This is not going to equal just x, but you're going to take this at this point, and I'm going to rewrite it. Negative 1 over negative 4 over x plus 2 plus 5. I'll never accept a fraction in a fraction. What's the opposite of dividing by x plus 2? Multiplying by x plus 2, but you got to do it top and bottom because otherwise you're not multiplying by a 1. This is a fancy form of 1 that's not changing the value when you multiply by 1. So you get negative this on top. Multiply here. Do you know that when you multiply and divide, they cancel or eliminate each other? And then 5 times x plus 2. As I said, I think you can see that it's really not going to be just x. Tell me when you've had enough here, but what would that be? 5x plus 10. So you get negative x minus 2, 5x, and what would that be? Plus 6. Anyway, that's not x, so they're not inverses. The next group of problems ask you to actually find the inverse. Would you agree that h of x means y? To find an inverse, you're going to do 2 steps. You're going to switch x and y, and then you're going to solve for y. Because you're switching them, I usually draw a line to indicate that things are changing now. So I'm going to reverse or switch the x's and the y's. So that y becomes an x, and this x becomes a y. So did I switch x and y? Yes. What's the next step? Solve for y. So the opposite of subtracting 3 would be to add 3. So I would have x plus 3 equaling the cube root of y. How do you get rid of the cube root? You raise it to the 3rd power. If you do it to one side, you have to do the same to both sides. So now you have this x plus 3 quantity cubed equaling y. So now I've done both of them. I switched x and y, and I solved for y. Now you're going to notice that they're not going to leave their answer that way. They're going to write it kind of strange, an f with a negative 1. And it's kind of strange because this usually means an exponent. But right here, that f of negative 1 means f inverse. It's a very specialized thing, and that's just the way you write the inverse. I don't care if you call it f inverse. I'll be happy if you give me the value. I'm just trying to inform you of what it's supposed to be. Let's see if we can do another one of these. Again, you simply switch x and y and solve for y. Did I have another one? Yes. G of x is y, isn't it? Did I tell you what to do? You switch x and y. 1 over minus 2. So now I'm going to switch x and y. That y becomes x. The x becomes y. So I switched x and y, and I'm about to solve for y. If I add 2, would I have this? Now you got to make a decision. I could actually solve it the proper way. Maybe you know that if I just flip the one side over, I could flip the other side over. In other words, do the reciprocal of both sides. And you have what y is, right? But suppose you don't know that. Do you agree that this is over a 1? Two fractions equal to each other, we can cross multiply. So you have y times x plus 2 equals, what's 1 times 1? 1. What's the opposite of multiplying by x plus 2? Dividing by x plus 2. And hopefully we end up with what I wrote over here. Anyway, they might refer to it as f inverse of x equals this. So that is what the inverse function would be.